Okay, so this is page 147, and we're gonna start by going over 1 through 9 to kind of review how we add the opposite when we subtract. So yesterday, we went through, again, guys, this is page 147. You need a minute to get there. You should have your packet open to page 147. Open to page 147. Guys, if you consistently sit here and do nothing and then come to me and you want to retake and redo and do all that, guess what? That's taking from my time. So if you're wasting my time now, I'm not gonna let you waste it again another time. Michael, what do you need to be successful right now? Michael, what do you need to be successful right now? Okay. We're on page 147. Yep, he doesn't come to me needing to understand things, so. He figures it out. All right, so we're subtracting a negative. When we subtract a negative or subtracting every time, watch your language, Ethan, we're going to add the opposite. So remember, we're going to keep the first, switch to addition, and switch the second sign.
That's only one number, parentheses, right?
So what? That's when we have two negatives next to each other.
Yeah, and then you're in parentheses.
Sometimes.
What page
But
was
sometimes, remember, you'll have to write your own. Michael, put it away.
it? Is that number 47?
What's 13 plus 63?
14 plus 6.
I'm on number 3. It is 13 plus 63. 76. I have 7 10s and 6 1s. This is very straightforward. What's 28 minus 18?
14.
14.
And you said it was 18, not 14.
Sorry, 28 minus 14.
That's it.
What's negative 10 minus nothing?
10.
Still negative 10.
Yeah.
We kind of set up number 6. Remember, subtracting is like adding the opposite. So if our signs are the same, what do?
Add the true value.
Yes, add the absolute values. Perfect. So what's 33 plus 33?
66.
And is it positive or negative?
Negative.
Negative. Well done.
When there's two negatives, we're pretty much.
Yes, we're pretty much adding 12, right? Negative 18 plus a positive 12. When our signs are different, we find the difference, which means to subtract.
It's 30.
So no, it's not 30.
It's not.
We have to subtract because our signs are different. What's,
Wow.
remember, we take big minus little. How are our signs different? We have a negative 18 and a positive 12.
Oh, keep change.
Yes, keep change, or keep switch, or keep change opposite. What's 18 minus 12, guys? 6. And is our bigger absolute value positive or negative?
Negative.
Negative. All right, so if we keep change opposite or keep switch, again, remember our signs are different. So we have to find the difference. So we have to subtract big absolute value minus little. What's 8 minus 3?
5.
And 2 minus 1.
1.
So is this 15 going to be positive or negative? Negative. Why negative? Good, I have more negatives, so my answer should end up being negative. This last one is the one on this row, where it's going to be a positive answer. Because we have a positive 40 and a negative 18. Well, this is just like 40, minus 18, because our signs are different. So we find the difference, which means to subtract. Big minus little. Can I take 8 from nothing?
No.
No, so please don't write 8 here, right? We have to borrow. 10 minus 8 is 2, and 3 minus 1 is also 2. And we just said it was going to be positive because our bigger number, the absolute value rather, of it is positive. Questions about 1 through 9 on page 147.
No.
10 minus 8 is 2. 8 and 2 is 10. 7 and 3 is 10. 6 and 4 is 10. 1 and 9 is 10. 5 and 5 is 10. Those are all ones you should know. I think you practice your 10 facts a ton, right? All right. So we're gonna hop back now to finish up this section, starting on page 141, excuse me, with example 3. So now we're subtracting with expressions. We did the top of page 141, but we have not done example 3. So the first thing we need to do is remember whatever x equals is what we're putting in for x. So do you see how they put in a negative 23 in for x? And they put in a 19 in for y, right? Then in order to subtract a 19, you have to add its inverse or add its opposite. So this is page 141. We're on example 3. Guys, some of you don't pay attention the first 2 times. You need to try and look at your clues. Well, we're in the first section, right? Or the second section. Are we in the second section? Yes, we're in 3-2, example 3, which is on page 141. Are we all on the same page now? All right. So do you see how they changed and took the opposite of 19? So if we start negative and we subtract, we're getting more negative. So they added the 2, right? They took the absolute values and added them together to get the 42. And they were both negative, so of course our answer is negative. Now we're going to do the same thing, except we have different values. We're putting that number in for P and that number in for Q. Take a minute and try this out. It says negative 21 is P and Q is 37. So write it out and then solve that problem. Here, let me check. Check. Good. So when we subtract from a negative, it's going to get more negative. So you end up finding the sum of these 2 absolute values and it's negative. Why are you so confused? So here's negative 21. That's P, right? Minus, see I'm bringing that minus down here. 37. Well, if you're just thinking about this as far as number lines go, subtraction means to go to the left, correct? So if I started at negative 21 and continued on 37 more to the left, as it goes left, it's getting more what? Negative. So I'm really adding these 2 because we just learned that when our signs were the same, we find the sum. Or subtraction is like adding the opposite. That's what they did. That's what they're doing here. They're trying to show you that subtraction is adding the opposite. So you could leave it like this as long as you're understanding and can visualize it. You know you're combining 21 and 37, which should be 58, right? And then you should know, is it positive or negative? Negative. All right, I do want to check out this explore activity with you a little bit. Because finding distance traveled by using a number line can be helpful to visualize it. Sometimes we don't always know what to do until we try it out. So here, I'm going to share this screen and then I'm going to line over here. I think we probably need to add lesson 3 to our dashboard. Did we start it yesterday? Okay. So let's add that. So we're in module 3, we're in lesson 2. Maybe, there we go. So let's add this to our calendar, so it will be in our dashboard. We started it yesterday. We're ending it probably on Monday or today. We'll see if we get done today. And that'll be there for you if you need it. So we're gonna hop along here
Do we have to do this?
to the Explore right now. Oh, that's what I wanted. We're gonna just look together. So all you have to do is look with me. There isn't gonna be anything for you to write. I just want you to be able to visualize it. Okay. So how is the distance between two integers on a number line related to the distance between two numbers? So we're looking here at the distance between exit 165 and exit 191. Do you guys know anything about exit markers?
No.
It's the same as the mile marker. So if you're getting off on exit 75, you're at mile 75 of that road. Now, some roads that run north to south might go through multiple states. And it might change over when it gets to the next state. Like you might get all the way down to 0 and then start counting up from 0. Or east to west, same thing. It usually changes at the state lines as far as miles go. So you're like that many miles on that road from one point of the state to the other. It's interesting, right? All right, so we're gonna look at this Explorer. So exits along highways are named by their numerical mile marker. For example, the road runs from west to east. Exit 14 is 14 miles away from the western state line. So they probably worded that a lot better than I just explained it. So suppose Stuart is traveling eastbound, passing exit 165 and exiting at exit 191. What is the difference he will travel? Record your answer. Okay, so let's think. How can we calculate this? How would you figure out how many miles it was from 165 to 191? What would you do? You would subtract, right? You would take your bigger and you would subtract your smaller to see how many miles it would be. So that's something we've probably done before. So suppose Rabia is traveling westbound on the highway, passing exit 191 and exit 165. How does her distance travel compared to Stuart's distance travel? Well, what's the difference? Are they still traveling the same distance?
Yeah.
Yes. What is different about the two, though? One's going one way and one's going the other way. So one's going west and one's going east. So I wonder if we need to figure out a way to denote the difference. So the distance between the two exits, the same as the distance between the destination and start exit numbers? Or how are they? So you would still say that they each traveled the same. But they might be a little bit different. So if I said 165 minus 191, if I subtract the bigger number from a smaller number, my answer is going to be negative. So how could we show a negative answer as a distance? Can you think about anything we've been doing with our negatives? Well, how do we figure out if our answer is negative or positive? Whichever one is bigger. What about it is bigger though? So it's kind of like the real value you said earlier, but what do we call it?
The absolute.
Absolute value. So the absolute value of that, they would be equal, right? Yeah. Very good. So if we write two different subtraction expressions and their differences that you could use to find the distance between the new numbers on the number line. Oh man, so if we said 1 minus 4, how would we do this? What could we say? Could we show two different subtraction? So what are two ways I could get to 1? I could say 1 minus 0. I could say 0 minus a negative 1. That's a little bit weird. That's really weird to think about, right? The distance could be 4 and 1. The distance could be 1 in multiple different ways. You start subtracting negatives. This is very abstract and obscure. So let's look at how we could do. So now we're thinking of -2 and -5. So we could come up with different subtraction problems to get these, right? What? No. So if we go back here, what's the distance between this 1 and this 4?
2.
So 1, 2, 3 hops. It takes me 3 hops. But if I could think about it the other way too, right? 1, 2, 3 hops to the left. So I could say 4 minus 1, or would give me the 3. I could also say 1 minus a negative 4, or just 1 minus 4. 1 minus 4 would give me -3. So the absolute value would be the same distance. That's a little weird. So let's look here. What's the distance between -5 and -2?
3.
Also 3, right? We would jump 1, 2, 3 places to the right, which would be +3, or you could jump 3 places to the left, which would be -3. Huh. I know this is weird for you guys to think through. So what is this jump? Now we had 2 negatives, we had 2 positives, but now our signs are different. So essentially we have to jump to the 0 and then jump 2 more. So how many jumps does it take to get to the 0?
4.
4, and then 2 more would make
2 or 6.
6. Or we jump to the 0 this way, so 2 and then 4 more. So still 6. I hope light bulbs come on soon. All right, so the distance between two integers on a number line can be modeled by subtracting. But what if the distance is negative? So if it's negative, we would have to take the absolute value of it. So could we always just take the absolute value of two numbers subtracted?
Yeah.
Yeah. So I think that could work. I think that's gonna help us a little bit. Hopefully that didn't confuse you like too much more. You are confused because you're tired. All right. So that's a little bit of what it would look like. So this learning is more concrete, right? Because we can see it and they're gonna give us step by step. So we can also watch the quick animation. Yes, dear.
Have you ever been tired? So like Like you can't learn, but you can copy.
Well, because it doesn't require you to think. All right, next resource is what we want. So I'm gonna hop to, this is subtraction expressions we just did. Here we go. This is gonna give us a nice video according to, yay, here we are. Are you ready? Let me turn up the volume because it's probably low.
Does this stuff come out of the
One way to find the distance between two integers is by using a number line. Start by plotting the two integers on the number line. Next, count the number of units between the integers. Counting the number of units shows that the distance between -4 and 5 is 9 units. You can also find the distance between two integers by using an expression. The distance between two integers is equal to the absolute value of their difference. Begin by writing an expression that shows the difference of the two integers between absolute value bars. Now simplify the expression. First, subtract the integers. Then find the absolute value. This method also shows that the distance between -4 and 5 is 9 units.
So that puts it much more concretely, tells you exactly what to do. So that's kind of nice. So now, why do we take the absolute value of the difference? Because we're talking about distance. Distance is negative, right, Elijah? Yeah, stay with us, dude. Okay, so now we're gonna look at our packets. Do you see how they plotted those 2 points? They counted the number between them. That was the 9, and there's 9 units between. Or you could use an expression. You could say -4 minus 5. That gives you a -9, and the absolute value of -9 was what? What are we filling in here? 9. Remember, these lines, these 2 lines here denote or show absolute value. So we do need to remember that, right? Can the absolute value ever be negative?
Yeah.
No. Absolute value is always positive because it's the distance between that number and 0.
I said no.
All right, so you can also use the expression 5 minus a -4 to represent the distance. Because you find the absolute value of the difference, the order of the integers does not matter. So the expressions, absolute value of -4 minus 5, and the absolute value of 5 minus a -4 are both equal to 9. Well, if you're looking at this wondering, wait, how did that equal 9? Well, remember, we keep, change, change. Or keep, switch, switch, perfect. So 5 plus 4 is 9, and of course, the absolute value of 9 is also 9. Okay? Are we all right there? No, that was a little bit weird getting in there. You're not all right. All right, 143. Example 4. So finding the distance between two integers. 1, use a number line. So start at -9, move until you reach 8, because we're finding the distance between -9 and 8. So -9 is right here. 8 is right here. Count how many hops it takes to get there. $17. Now that was kind of a lot of work. I also might think, oh, it takes me 9 to get to 0 and 8 more. So that's a total of also 17. You see that? Method 2, use the absolute value. So to find the distance between integers, you can find the absolute value of their difference. So -9 minus 8, it's getting more negative. This is like -9 plus a -8. So this is the absolute value of -17, which is what? 17. That's our distance. So the distance, either way you look at it, whichever method you choose to use, should be the same, which is 17 in this case. All right, find the distance between -5 and 9 on a number line. Now, again, you can use method 1 or method 2, or think it through, right? How many hops would it take to get to 0, combined with how many more? So what do we got here? 14. So you could say -5 minus 9. You could say 9 minus a -5, right? Or you could draw out your number line. Hmm? Yes.
How come when you like wake up, you're not that tired, but then as soon as you go to do something, where people are talking, you're just out of it?
I don't know. So remember, to get here, it is 5 units. To get here, it is 9 more units. So if I combined those, I would also get 14. So some way, somehow, hopefully you are getting 14 in the distance between numbers.
Yeah.
Excellent. All right. Holy cowabunga. All right. Example 5. The highest point in California is Mount Whitney with an elevation of 14,494 feet. The lowest point is Death Valley with an elevation of -282 feet. What is the distance between the height of Mount Whitney and the depth of Death Valley? So they wrote it out. They took the first height and they subtracted the second height. See what happens when you subtract a negative? You're really adding. So they added them together to get that. The absolute value of that is still just that. So now, this iceberg is 55 feet above sea level, while the bottom is 385 feet below sea level. So if we're finding the difference, we're subtracting the two. But how would I show this height? -385. So what happens? I should end up adding them. Michael, throw it away now. You know what? It's distracting all of us, so throw it away. Should be enough. So subtracting a negative, we would add them. What did you get? Five and 5 is 10. 6 and 8 is 14. 440? 440 feet between the two. Or you could think, okay, it takes me 55 to get down to 0, and then an additional 385 to get to 385 below sea level. Again, I'm still adding to find that distance, right? All right, 145. All right, minimum and maximum temperatures. So greatest variation in temperature. So we're taking one and subtracting the other. So should we do max minus min? Sure. So 253 minus what? What's the min? -387. Be careful here. 70 minus -225. So all of these we're taking the max minus the min and trying to solve those. Okay, so use these last few minutes to try those out. And on Monday, we'll be getting in a lot of practice after we review that applied problem there. So max minus the min, max minus the min. Remember, if we are subtracting a negative, we're really adding. What's your max minus your min here? What's 864 minus 864?
0.
0, very good.
No, he's on a calculator.
All right, so try those. 2, 3.